Hey everyone, and welcome back to the Foundry by Forge College. So, here we are, Module 4 of our Solana mainnet course. This is it. You spent weeks building out your capstone, writing endless tests, and, let's be honest, probably drinking way too much coffee. And now you're staring down the barrel of an actual mainnet launch. Hitting that deploy button for the very first time, well, it feels exactly like sitting in mission control during a rocket launch. It is totally exhilarating, but also kind of terrifying, because if you haven't double-checked your O-rings, things can get very messy very fast. So today, we're taking that readiness scorecard we talked about in the last explainer, and we are turning it into a concrete, executable deployment strategy. Okay, let's look at the flight plan for today's explainer. First, welcome to the launch pad. Then, the release manifest. Third, choosing your rollout strategy. Moving into handling Solana migrations. Then, your final checklist. And finally, ready for mainnet. Let's go!
Let's dive right into Section 1. Welcome to the Launchpad, translating readiness to action. Moving on to Section 2, the release manifest, which is essentially your flight computer. Think about your release manifest exactly like a spacecraft's flight computer. Look, when you're stressed out and staring at a blinking terminal, the last thing you want to be doing is frantically hunting through Slack messages, trying to remember what exactly you're supposed to deploy. No way. You need a single, rock-solid source of truth, and we build this using something called semantic versioning. This is just a structured numbering system. Think 2.1.0 versus 2.05. Now, we don't do this just to look hyper-organized. We do it because it allows machines to safely parse and verify which software release is the absolute newest. These exact version numbers define your explicit rollback targets. They are literally your emergency parachutes. Do not jump without them.
So what actually goes into this flight computer? Well, your manifest needs to contain a few very specific things. You've got your version tag. You need the exact path to your compiled BPF program binary, the actual smart contract code that's going on-chain. It also needs any migration plans, your acceptance gates, along with hard metric thresholds, and of course that crucial rollback candidate. Keep this single file under strict version control. That way your automation scripts know exactly what to execute without any guesswork.
Right. Section 3. Choosing your rollout strategy, or mapping out the launch trajectory.
Choosing your trajectory is all about aligning your expected failure modes with the smallest possible blast radius. Basically, if things go sideways, you want to be able to recover incredibly fast. So, we've got three main strategies here. First is blue/green. This is where you swap traffic instantly between parallel environments. It is absolutely perfect if you don't have any complex state migrations. Next up is canary. Think of this like taking a tiny taste test before you serve the entire banquet to your guests. You route a very small sliver of traffic, watch the behavioral metrics closely, and then slowly ramp it up. And finally, we have phased rollouts, which are released like clearly partitionable user cohorts or regions. You just need to pick the one that actually lets you sleep at night.
Okay, moving right along to Section 4, handling Solana migrations. Basically the payload physics of our launch.
Now, deploying on Solana specifically kind of changes how we have to view these rollout strategies. Mainly because of the mechanics of the BPF upgradable loader. We have to distinguish between two things: reversible upgrades and irreversible migrations. Reversible upgrades are pure code-only changes that preserve your existing account layout. If something breaks, no big deal. You just downgrade the program and the data is still perfectly compatible. But irreversible migrations? That's when you start altering account data layouts or deriving new PDAs. Once you change the actual shape of the data on-chain, rolling back just the code will trigger massive errors. It is a one-way trip for sure. For those, you absolutely must adopt a strict canary approach.
And when I say canary approach for those persistent state migrations, I mean tiny. Your initial canary traffic cohort should be minuscule. We are talking no larger than 0.1% to 0.5% of your total production traffic. This tiny, tiny sliver is what lets you safely observe how your new logic interacts with real, live data without risking the digital wallets of your entire user base.
Let's get into Section 5, your final checklist, the final countdown.
All right, it is time to tie all these deployment strategies into a concrete, executable YAML deliverable. This isn't just some casual to-do list. It is a rigid control mechanism specifically designed to prevent a multi-million-dollar typo. The workflow hits 5 core stages. First, you prepare your artifacts and manifests. Second, rehearse everything on a snapshot testnet. Seriously, do not skip that. Third, stage the release to a low-traffic cohort. Fourth, verify your acceptance gates. And fifth, you either promote the traffic or execute a rollback. Remember, every single step here needs an assigned owner and a strict abort criterion.
Inside that pre-mainnet checklist YAML file, you need to get highly specific. You define the precise artifact target, like build/program.so. You literally tag the named owners, like, hey, @release_lead, this is on you. You set up your acceptance gates, for example, demanding that your P99 latency stays under 250 milliseconds. You link your account migration plan, and you explicitly state your hard rollback candidate version. You got to write all of this down before anyone even breathes on a production key.
Now, here is a quick challenge for you. Do your acceptance gates have automatable verification? Honestly, if your checklist just says, check if latency is okay, well, that's a suggestion. It's not a gate. Every single gate needs to be tied to an executable script or at least a named human who knows the exact CLI command to run. I highly recommend doing peer reviews of these checklists before mainnet. Have a teammate actively try to poke holes and find a failure scenario your gates might have totally missed.
And finally, Section 6, ready for mainnet. Ignition sequence, start.
By doing all this, you're transforming from someone who just writes smart contracts into a true systems engineer. And systems engineers, they rely on data. Which leads me to this crucial rule of thumb. Tie alert thresholds directly to acceptance gates, so Signal drives the promote or rollback decision rather than guesswork. Look, in the heat of a deployment, you might be really tempted to just ignore a minor error spike to get the launch over with. Don't do it. Let the data decide. If a gate fails, you roll back, period. The artifacts that we've mapped out today form the exact control plane we'll be using in the next phase. You've done the really hard work of planning and setting the boundaries. So next time, we're going to use this control plane to actually execute a live stage deployment.
So, I'll leave you with this final thought. Are you ready to flip the traffic, or do you need to check your parachutes one more time? Take the time to dry run your manifest today. And remember, to master more advanced Web3 engineering concepts or just review this entire capstone sequence, head over to forge.college to explore all our resources. Thank you so much for joining me on this explainer, and I will see you on the Launchpad in the next one.